Hello, hi class. This is Arnav. Today I'll be presenting my code that I did for assignment 2. So let's get started. First of all, I want to start with question number 1, which is about collision handling and linear probing. So the hash tables uses linear probing to handle collisions. If two bookings hash to the same index, the table checks the next slot until it finds an empty one. For example, if index 5 is occupied, it checks index 6, then 7, and so on. If I check in my code, index, so in my code, this is the line that shows that. Next, to show the output and explain the storage, here's my code that I've ran. So let's add 3 bookings. The hash table stores them based on their hash index, and collisions are resolved using the linear probing. And so if you look at it, you can see the bookings. Okay. So this is the output that I get. So the bookings are stored in table based on their hash index. If two bookings collide, linear probing finds the next available slot. Next is to demonstrate the search function. So now let's search for a booking. The search function calculates the hash index and uses linear probing to find the booking. And in my code, I have it over. Yeah, so in my code, this is a demo code where I show that. And the sample output that it brings out would be here. Searching for demo ID 102. Yeah, so the search function starts at the hash index and probes until it finds the booking or determines it doesn't exist. Then to show the booking removal and table update. So finally, let's cancel a booking. The slot is marked as deleted and the table is updated. So the demo code can be found. Over here. This is to show the booking cancel, and this is to show to display the booking. And the output, this can be showed as over here. Where is it? Yeah. So it can be seen over here. This is to show when a booking is canceled, the slot is marked as deleted, and the table is skipped when it skips, and the table skips it when displaying books. Okay, now so question number 2. I linked lists for emergency hospital management system. So I'm going to explain how patients are prioritized by severity. So in this program, patients are prioritized based on their severity level from high, moderate, and low. When a patient is added, the linked list is traversed to find the correct position where the patient's severity fits relative to others. For example, a patient with high severity is placed at the front of the list, while a patient with low severity is placed at the end. So here's a code that specifies that. So some key points about this is patients with higher severity are placed at the front of the list, and patients with the same severity are added in order of arrival. Next, to show the output and explain the order of patients. So let's add 3 patients with different severity levels. The linked lists ensure that patients with higher severity are prioritized. Here's the output. So just give me 1 second. So here's the code for that, and the sample, the output of this code would be something like this. So something like this. So the patients are displayed in order of the severity level. John Doe is with high severity, so he's at the top. Followed by Jane Doe with moderate, and Alice with low severity. And then to demonstrate how the search function works, now let's search for a patient using their ID. The search function traverses the linked list to find the patients with the matching ID. So here's the code that specifies that. And then in the output code, you can see that over here, the search function starts at the head of the list and checks each node until it finds the patient with ID 102. And once found, the patient's details are displayed. Now to show how the patient is removed and the list is updated, finally, so let's try to remove a patient. When a patient is removed, the linked list updates the pointers to skip the deleted node. So this part of the code shows that. And so the output of that code would be something like this, to show that after removing the patient with ID 102, the linked list updates its pointers and the remaining patients are displayed. Notice that Jane Doe is no longer in the list. If you check over here, you can see that it's no longer in the list. Question number 3 is about binary search tree for real estate property listings. So in this program, the properties are stored in a binary search tree, also known as BST, stored by the unique property ID. When a new property is added, it is placed in the correct position based on its ID. Smaller IDs go to the left, and the larger IDs go to the right. So this is the code that I wrote right over here. And some of the key points about this is that properties are sorted by the property ID, and small IDs are stored in the left subtree, and the larger IDs are stored in the right subtree. So after running the code, this is the output it should be giving you. So the properties are displayed in ascending order of their IDs. So you can see it's 101, 102, 103. And this is because the BST performs in an in-order traversal, which visits nodes in sorted order. Now to demonstrate how the search function works. So now let's first search for a property using its ID. The search function traverses the BST to find the property with the matching ID. So if you check this part of the code, that's where I do it. Then my output of the code is over here, as you can see. So the search function adds at the root and compares the target ID with the current node. If the target ID is smaller, it searches the left subtree, and if larger, it searches on the right subtree. Once the properties details are found, the details are then displayed. So now let's look at how the property is deleted and the tree is updated. So finally, let's delete a property. When a property is deleted, the BST is updated to maintain its sorted structure. So this part of the code does that. The output of this code will be like something like this. So after deleting the property with ID 102, the BST is updated and the remaining properties are displayed in sorted order. You can also notice that how the tree maintains its structure as well. Basically, that's about it for my presentation. Thank you.